Hello, sir. Good afternoon, everyone. My name is Sunil and Sidnal. Today, I'm going to give a seminar presentation on 3D printing under the guidance of Professor Srinath Gavarichar, Mechanical Department, Jain College of Engineering, Belgavi. Let's see the content of the seminar: 3D printing, general principles, different methods, applications, and conclusions. 3D printing. Additive manufacturing or 3D printing is a process of making a three-dimensional solid object of virtually any shape from a digital model. 3D printing is achieved using an additive process where successive layers of material are laid down in different shapes. Additive process, it refers to a process by which digital 3D design data is used to build up a component in layers by depositing material. Depositing material means phase transition in which gas transforms into solid without passing through the liquid phase. For example, bed forms. And 3D printing is an synonym for additive manufacturing for series production. The general principles are modeling, printing, and finishing. Let's go through the modeling. Additive manufacturing takes virtual blueprints from computer-aided design, CAD softwares, or animation modeling softwares and slices them into digital cross sections for the machine to successfully use as a guidance for printing. 3D modeling is the process of developing a mathematical representation of any surface of an object in three-dimensional through specialized softwares. There are many 3D modeling softwares, for example, Autodesk Maya, Autodesk Mudbox, Cinema 4D, Modo, Autodesk 3D Max, ZBrush, Substance Designer, Blender, etc. Printing. To perform a print, the machine reads the design and lays down successive layers of liquid, powder, or sheet material to build the model from a series of cross sections. These layers, which correspond to the virtual cross sections from the CAD model, are joined together or automatically fused to create the final shape. The primary advantages of this technique is its ability to create almost any shape or geometric feature. And finishing. Uh, through the printer produced resolution is sufficient for many applications. Printing a slightly oversized version of the desired object in standard resolution and then removing metal with the higher resolution subtractive process can achieve a higher resolution. There are some finishing methods. They are ABS, Vero Black, PLA, etc. There are many different methods. Let us discuss one by one. The most commonly used 3D printing process is a material extrusion technique called FDM. It is a fusion deposition modeling. It is the technologies before SLA and SLS. It is the invented after the other two most popular techniques, SLA and SLS. SLM selective laser sintering and selective laser sintering and stereolithic stereolithography, and FDM is typically the most inexpensive of the three by a large margin, which tends to the popularity of the process. Now let's go to the first one, stereolithography. Stereolithography is an additive manufacturing process using a vat of liquid UV curable photopolymer resin and a UV laser to build up parts a layer by layer at a time. Okay, let's zoom into this. The design model in the computer is sent to the 3D printing machine using STL. This STL converts the computer language into machine language and it divides the design model to various layers. Here the movable in this diagram you can see the different parts of the 3D printer. Here the movable build platform moves up and down. The resin tank contains the photopolymer liquid that is UV curable resin. From the laser source, the rays pass into the mirror. Here, the ultraviolet rays will produce. They are made to contact with the liquid and solidifies the liquid. The required layer will be occurred. Then, liquid using elevator, the platform moves down. Again, the UV rays fall on the liquid. Another layer will be formed and the process continues till the last layer and the layers get combine and the required product will be occurred, and it will send to a finishing processes. CAD, computer assisted design programs, help users create STL files for the 3D printers to read, and STL, stereolithography file format, a file format which uses many little triangles to make a three-dimensional plot of the objects in their service. And I have shown the diagram here. This how looks the 3D designed model in the computers. And the second one is selective laser sintering. Selective laser sintering is an additive manufacturing technique that uses a high power laser, for example a carbon dioxide laser, to fuse small particles of plastic, metal, direct metal laser sintering, ceramic or glass powders into a mass that has a desired three-dimensional shape. Here in this diagram you can see the two cylinder piston connection, and here the piston connection is done when one cylinder consists of powder and another one is of to get the layers of the product. The rays from the laser transfer into the scanner. Here the CO2 rays are produced and they are made into the contact with the powder. Initially the piston of cylinder 1 moves up and the roller move on the powder, and the CO2 rays are made to fall on the powder and the required layer will be formed. The piston of cylinder 2 moves down, and this in the same way the layer by layer of the powder will be formed by the and the final product will be occurred and the finishing will be done. The next one is fusion diffusion modeling. This was the most used method of 3D printing. Fusion diffusion modeling is an additive manufacturing technology commonly used for modeling, prototyping, and production applications. You can see a connection of rollers and feed rollers, a nozzle and a platform. Initially here the roller will supply the plastic filament to the extrusion nozzle through the feeder rolls. In nozzle we have a melter, it melts the plastic, and through nozzle the initial layer will be layers will be formed and it solidifies, and the process continues and the layer by layer formation occurs, and finally the product will be formed, then it is sent to the finishing processes. And the last one is laminated object manufacturing. Laminated object manufacturing is a rapid prototype system developed by Halsey's, and in it layers of adhesive coated paper, plastic or metal laminates are successfully glued together and cut to shape with a knife or a laser cutting. We can see here a supply roll, take-up roll, a block, platform, and a laser and a mirror supply. The supply roll will supply the sheet material, and the take-up roll will collect the sheet material using the laser. And using the laser, the sheet material is cut to this shape, and then the platform moves down, and the roller start rotating, and the second layer will be cut to the shape, and the heated roll will move on the sheet, and it solidifies the layers, and the process continues till the last layer occurs, and the final product will be formed and it is sent to the finishing processes. There are some applications of this 3D printing. It's a prototyping, creating a solid part, modeling custom parts, designing through softwares, for research purposes also. In conclusion, nothing communicates ideas faster than a three-dimensional part or model. With a 3D printer, you can bring CAD files and design ideas to life right from your desktop. Text from feet and function and as many design variations as you like with function parts. Through this 3D printer, we can conclude that the process of manufacturing the product is so fast, and we can manufacture the products even easier among the other methods. Thank you.